Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll be exploring the remarkable wonders of our very own planet. We'll discover some of the amazing ways life has not only learned to survive, but to thrive here on Earth. Life surrounds us in every form imaginable. It glows softly in the deep ocean, clings to rocks in the driest deserts, and drifts unseen in the air we breathe. Some creatures have existed almost unchanged for hundreds of millions of years, while others can survive in places so extreme they seem impossible. Each one is like a tiny miracle, carrying a piece of the grand puzzle that connects us all. If you enjoy these gentle journeys, I invite you to like and subscribe, or share your favorite fact in the comments down below. It helps others find their way here too, one sleepy soul at a time. But for now, there is nothing you need to do but rest. Breathe gently, listen carefully, and allow your thoughts to soften as the stories of life unfold. Let's begin. Life on Earth may have begun in deep-sea vents. When we think of life's origins, it's easy to picture warm ponds under a gentle sun. But scientists now believe the story may have begun in the darkest places of all, deep-sea hydrothermal vents. These strange chimney-like structures spew scalding water rich with minerals from Earth's interior. Though it sounds inhospitable, the chemistry here is extraordinary. The minerals act like catalysts, creating tiny chambers where simple molecules may have assembled into more complex forms. Some researchers believe that these mineral pockets acted as the very first laboratories for life, cradles where fragile beginnings were shielded from the chaos of early Earth. Even today, these vents are teeming with creatures that live without sunlight, drawing energy directly from the chemistry of the Earth itself. It's humbling to imagine that our shared story may have started not with warmth and light, but with heat, pressure, and darkness. Some creatures can survive being frozen solid. Imagine being frozen like a block of ice, and then waking up again as if nothing happened. For some creatures, this is not imagination, it's survival. Certain frogs in North America, like the wood frog, can allow their bodies to freeze almost completely in winter. Their hearts stop beating, their blood ceases to flow, and yet they do not die. Special chemicals in their bodies, such as glucose, act like natural antifreeze, protecting their delicate cells from bursting. When spring arrives and the ice melts, these frogs thaw out and hop away, unharmed. Insects and tiny invertebrates have developed similar tricks, surviving deep freezes that would kill most other life forms. These adaptations remind us that life is not fragile, but endlessly inventive, finding ways to endure even in states that seem like suspended animation. It's as if Earth has written into its script the ability to pause and resume the rhythm of life. There are animals that live entirely without sunlight. We're used to thinking of the sun as the ultimate source of life. Plants drink in its rays, animals eat those plants, and the cycle continues. Yet in the deep ocean, far below where light can ever reach, entire ecosystems thrive in utter darkness. Around hydrothermal vents, blind crabs, giant tube worms, and ghostly fish live in abundance. Instead of sunlight, they depend on chemosynthesis, a process where bacteria harvest energy from chemicals like hydrogen sulfide pouring from the vents. These bacteria form the base of a food chain that flourishes without a single photon of light. In caves deep underground, other species have adapted similarly, never knowing the sun. Their eyes shrink or disappear entirely, and they develop heightened senses of touch or smell to navigate. Life, it turns out, is not tied to light at all costs. It can build its own worlds in darkness. Jellyfish have drifted through Earth's oceans for over 500 million years. Jellyfish are older than dinosaurs, older than trees, older than almost anything we recognize as life today. They have pulsed gently through Earth's oceans for more than 500 million years, surviving mass extinctions that wiped out countless other species. Their bodies are almost otherworldly, simple sacks of tissue, 95% water, lacking bones, brains, or hearts. Yet their design is so effective, it has hardly changed across geological ages. They drift with the currents, sometimes glowing with ethereal light, sometimes gathering in blooms so vast they can be seen from space. Despite their simplicity, jellyfish are skilled survivors, able to regenerate damaged parts and thrive in waters where many fish cannot. Watching a jellyfish pulse slowly through the sea is like gazing into deep time itself, seeing the persistence of a design that has worked for 500 million years and shows no sign of fading away. Some microbes can eat rocks for energy. Most of us imagine life eating plants, animals, or sunlight. But some microbes have a different menu altogether. They feed directly on minerals and rocks. These organisms, called lithotrophs, can strip electrons from substances like iron, sulfur, or even uranium, using this chemistry to power themselves. Deep beneath the Earth's crust, in places where no light and no organic food ever reach, entire microbial communities survive on this strange diet. Some scientists believe they represent a glimpse of what life might look like on other planets. Simple, hardy, and able to draw sustenance from bare stone. Astonishingly, these microbes can even change the chemistry of their surroundings, slowly altering the minerals they touch. Over billions of years, they may have helped shape Earth's environment itself. When you think about life's resilience, picture these invisible miners, patiently eating rocks in the dark and thriving where almost nothing else could. The oldest known living organism is more than 10,000 years old. When we measure our own lives in decades, the ages of Earth's oldest organisms seem almost incomprehensible. Deep in the Arctic, clonal colonies of seagrass, known as Posidonia oceanica, have been alive for more than 10,000 years, quietly spreading beneath the waves. On land, certain clonal trees, like the quaking aspen pando in Utah, cover entire forests with genetically identical stems, all linked by a single root system that has endured for millennia. These living beings have witnessed ice ages come and go, outlasting countless generations of animals and humans. They remind us that longevity in nature is not always about the individual, but about continuity, a life form that endures by continually renewing itself. Standing in the presence of such ancient beings, one feels time stretch outward, as though the heartbeat of the earth itself is measured not in years, but in the breathing of forests and oceans. Some trees can clone themselves across millennia. Trees may seem still and solitary, but many carry within them a secret power, the ability to clone themselves. When branches touch the ground, they can sprout roots, and over time, new trunks rise. Some species, like the willow and poplar, spread this way, creating vast stands that are genetically identical. The most famous of these is Pando, the trembling giant of Utah, a forest of 40,000 stems that are all part of one ancient individual, thought to be tens of thousands of years old. Unlike animals, which usually live and die as individuals, trees can persist by replicating themselves, sending new shoots skyward while older ones decay. The forest is both mortal and immortal, both ancient and ever-renewing. It's a reminder that life can cheat time not just by endurance, but by spreading itself across generations in a quiet, collective persistence. A fungus in Oregon covers nearly 10 square kilometers. In the Blue Mountains of Oregon lies one of the largest living organisms on Earth, a fungus known as Armillaria ostoi. At first glance, it appears as nothing more than scattered mushrooms poking through the forest floor. But beneath the soil lies a vast web of filaments called mycelium, all interconnected, stretching across nearly 10 square kilometers. This colossal being is thousands of years old and weighs an estimated hundreds of tons. Though it grows invisibly, its reach dwarfs even the largest animals. Its filaments invade tree roots, slowly digesting wood, recycling the forest from the inside out. Walking across that forest, you might think you're surrounded by many individual trees and mushrooms, but in truth, you're treading on the living skin of one giant organism, a hidden giant that quietly holds sway over its domain. It's both eerie and awe-inspiring, a reminder that the Earth is full of secret giants. There are more microbes in your body than human cells. If you think of yourself as a single individual, science offers a humbling correction. You are an ecosystem. For every human cell in your body, there are at least as many microbial companions, if not more. Bacteria, viruses, fungi, and archaea live in your skin, your mouth, your gut, and deep within your tissues. Collectively, they are called the microbiome, and they influence everything from digestion to mood, from immunity to energy levels. Many of them are essential. Without them, we could not survive. Others coexist peacefully, neither harming nor helping. Altogether, they form a teeming city within you, one that shifts and changes with your diet, environment, and experiences. When you realize that more of you is microbial than human, it becomes clear that life is never solitary. Even within our own bodies, we are networks, a cooperative dance of countless beings sharing one vessel. Tardigrades can survive the vacuum of space. Tardigrades, often called water bears, are tiny creatures that look like wrinkled, eight-legged pillows with snouts. They are less than a millimeter long, but their resilience is legendary. When conditions turn harsh, when water dries up, temperatures plunge, or radiation spikes, they go into a state called cryptobiosis, drying out almost completely. In this state, they can endure extremes that would kill almost any other organism. Scientists have blasted them with radiation, frozen them, boiled them, and even exposed them to the vacuum of space. And they survived. After years in suspended animation, they can be revived simply by adding water. Their secret lies in special proteins and sugars that stabilize their cells, protecting DNA and membranes from damage. They are living proof that life can endure where it seems impossible. If creatures like tardigrades exist here, perhaps something equally hardy could endure on distant worlds. Some fish can switch sex during their lifetimes. In the hidden world beneath the waves, gender is not always fixed. Many fish have the astonishing ability to change sex during their lifetimes. In clownfish communities, for example, the largest and most dominant member becomes female, while the others remain male. If she dies, the next largest male transforms into a female to take her place. In wrasses and groupers, males sometimes shift to females, or the reverse, depending on what the group needs to maintain balance. These transformations involve profound biological changes, entire reproductive systems reshaping, hormone levels shifting, even behaviors adapting. It's a reminder that the categories we often think of as rigid can be fluid in nature. In the ocean, survival often depends on flexibility, and these fish show us just how adaptable life can be, rewriting its own rules to ensure the continuity of its lineage. The axolotl can regrow its own brain tissue. The axolotl, sometimes called the Mexican walking fish, is no ordinary amphibian. With its feathery gills, perpetual smile, and youthful appearance, it already seems otherworldly. But it's true, marvel lies in regeneration. Unlike humans who heal with scars, axolotls can regrow entire body parts, limbs, spinal cords, hearts, and even sections of their brains. When injured, specialized cells in their bodies reset themselves to a more flexible state, like stem cells, and rebuild the missing structures with astonishing precision. Scientists study axolotls intensely, hoping to unlock the secrets of this regenerative power. Imagine if humans could regrow damaged organs or repair spinal injuries as effortlessly as these small salamanders do. For the axolotl, regeneration is not a miracle but a way of life, a natural rhythm of renewal that keeps it perpetually young and endlessly resilient in the waters it calls home. Some frogs can hold their breath for months. In the cold silence of winter, certain frogs perform a feat that seems almost impossible. They stop breathing altogether, burying themselves beneath mud or leaves, and enter a suspended state. The marsh frog, for example, can remain underwater for months, relying on oxygen absorbed directly through its skin. Some species slow their metabolism to such a crawl that they can survive on almost no oxygen at all, essentially putting their bodies on pause until spring arrives. It's a delicate balancing act, allowing them to endure conditions that would suffocate most other creatures. When warmth returns, they awaken, croaking once more as if nothing had happened. This ability to wait out harsh seasons in silence is a reminder of nature's patience, that survival often depends not on action, but on stillness, on holding steady until the world becomes welcoming again. Certain shrimp can create cavitation bubbles hotter than the sun. Among the most extraordinary animals on Earth is the pistol shrimp, a tiny creature with a claw that functions like a weapon from science fiction. When it snaps this claw shut, it fires a jet of water so fast it creates a bubble of low pressure. As the bubble collapses, it generates a shockwave that stuns or kills nearby prey. In that brief instant, the collapsing bubble produces temperatures hotter than the surface of the sun, and a flash of light visible under special equipment. All of this from an animal barely a few centimeters long. Pistol shrimp colonies can sound like crackling fires beneath the ocean as thousands of claws snap in unison. It's almost unbelievable that something so small could harness such immense power. Proof that even in the tiniest bodies, nature hides the ability to unleash forces rivaling the stars. Some birds navigate using Earth's magnetic field. How does a bird know where to go when it crosses oceans or continents, often traveling thousands of kilometers with astonishing precision? Scientists have discovered that many species can actually sense Earth's magnetic field, using it like a built-in compass. This sense, called magnetoception, is thought to involve tiny magnetic particles in their tissues, or special light-sensitive proteins in their eyes. Some birds may literally see magnetic fields as faint patterns overlaying the world around them. This hidden sense guides them across vast, featureless skies where landmarks are absent. It allows Arctic terns to migrate from one pole to the other and pigeons to find their lofts from unfamiliar places. To us, Earth's magnetism is invisible, unfelt. But to these birds, it is a quiet map etched into the very air, pointing them unerringly across the globe. Monarch butterflies travel thousands of kilometers to migrate. Every autumn, millions of monarch butterflies set out on one of the most remarkable migrations in the animal kingdom. Fragile, paper-thin wings carry them from Canada and the United States all the way to the mountain forests of central Mexico, a journey of thousands of kilometers. What makes this feat even more astonishing is that no single butterfly completes the round trip. Generations are born along the way, each continuing the journey their ancestors began. By the time they return north in spring, they are the great-grandchildren of the butterflies that started the migration months earlier. Guided by instincts we barely understand, They find their way to the same forests, even the same trees, year after year. To watch a forest fill with orange and black wings is to witness living poetry, delicate travelers who follow invisible maps written into their very being. Octopuses have 3 hearts and blue blood. The octopus is one of Earth's strangest and most intelligent creatures, and its very blood and circulation set it apart. Unlike humans who rely on 1 heart, octopuses have 3. 2 pump blood through their gills, while the third pumps it to the rest of the body. And instead of iron-based red blood like ours, theirs is copper-based, turning it a pale, icy blue. This adaptation allows them to survive in cold, oxygen-poor waters. Yet the marvel of the octopus doesn't stop there. They can squeeze through impossibly small spaces, change their skin's color and texture in an instant, and solve puzzles with startling ingenuity. To encounter an octopus is to meet an alien intelligence, a creature whose body and mind evolved along a completely different path, reminding us that there is no single blueprint for life. Crows can recognize human faces. Crows are among the most intelligent birds, with memories and reasoning abilities that rival some primates. One of their most striking skills is the ability to recognize individual human faces. In experiments, crows have remembered and reacted to people who treated them poorly, even warning other crows about specific individuals. Years later, they can still recall those faces. But it's not only about grudges. They also recognize friendly humans, sometimes leaving gifts like shiny pebbles or bits of glass in return for food. Their ability to distinguish and remember faces shows a depth of social intelligence that feels uncannily close to our own. Watching a crow tilt its head and study you, you might wonder who's really observing whom. Behind those black eyes is a mind that remembers, judges, and perhaps even passes down stories to its flock. Dolphins call each other by unique names. In the shimmering world beneath the waves, dolphins live in tight-knit communities full of play, cooperation, and communication. One of their most remarkable traits is that they use distinct whistles to identify each other, the dolphin equivalent of names. Each calf develops its own unique signature whistle, which it carries through life. Other dolphins use this sound to call out to them, and individuals can recognize their name even when produced by another dolphin. This ability suggests a form of self-identity and social awareness rare in the animal kingdom. Dolphins have been heard calling the names of companions separated from them, almost like roll call in the sea. To imagine a pod of dolphins weaving through the water, calling out names in a chorus of whistles, is to glimpse the sophistication of a culture that thrives beneath the waves, echoing with voices we are only beginning to understand. Elephants can detect storms hundreds of kilometers away. Elephants are giants not only in size but in sensitivity. With ears that act like great receivers and feet that detect subtle vibrations, they can sense approaching storms from astonishing distances, sometimes hundreds of kilometers away. Researchers believe they may pick up infrasonic sounds, rumblings far below the range of human hearing, created by thunder or shifting weather systems. This gives them time to begin long migrations toward water and shelter. Elephants have also been observed communicating with each other using these same low-frequency calls, carrying messages across vast landscapes. For creatures so massive, their awareness is finely tuned, responding to whispers of the earth and sky. To stand near an elephant is to be near a being deeply connected to its environment, one that feels the pulse of the planet in ways we can scarcely imagine. Whales sing songs that change over time. Beneath the ocean's surface, where light fades into endless blue, humpback whales sing. Their songs are long, haunting sequences of moans, cries, and melodies that travel for hundreds of kilometers through the water. Each song can last for hours, looping in cycles as the whale drifts or swims slowly along. But what makes these songs astonishing is not only their beauty, but their change. Over months and years, whales collectively alter their songs, adding new phrases while dropping others, as though the entire population agrees to remix the melody. These changes ripple through oceans like cultural waves, with one region's song gradually spreading across others. Sometimes entire groups adopt a brand new song almost overnight. Scientists still don't know why whales do this. Is it courtship, communication, or art for its own sake? Whatever the reason, their voices turn the ocean into a living symphony, always evolving, always alive. Some bats use polarized light to navigate. When the sun dips below the horizon, twilight paints the sky with hidden patterns. Light scatters through the atmosphere in a way that creates polarized bands invisible to us but legible to other eyes. Certain bats, remarkable navigators of the night, can perceive these faint cues. They use them to orient themselves on long journeys, treating the sky like a silent compass etched in shifting light. Combined with echolocation, this hidden map allows bats not just to dart through forests, but to migrate over vast distances, finding their way with unerring accuracy. Imagine seeing the dusk sky not as fading color, but as a web of guiding lines, glowing softly, pointing the way home. For bats, the world holds extra dimensions of information we cannot perceive. Their flight reminds us that the Earth is full of secret signals, and that nature's navigation can be as subtle as it is profound. Slime molds can solve mazes without a brain. Slime molds are not animals, nor fungi, nor plants, but something uniquely their own. They exist as vast single cells that creep slowly across surfaces, extending delicate tendrils in search of food. Without neurons, without brains, they nonetheless display a kind of intelligence that challenges our definitions of thought. In laboratory experiments, scientists placed slime molds in mazes with food sources at 2 exits. Gradually, the organism expanded into the corridors, retracting from dead ends, reinforcing the shortest route and eventually tracing the most efficient path, as though solving the puzzle. They can even anticipate repeating events, behaving as if they remember what came before. For an organism with no nervous system, this is astonishing. Slime molds suggest that problem-solving is not limited to brains, but can emerge from the collective behavior of cells themselves. They embody a quiet truth. Intelligence is not a form, but a function of life. Some ants farm fungi underground. Long before humans planted fields and tended crops, ants were already practicing agriculture. Leafcutter ants, for instance, march in endless processions, cutting green fragments from plants and carrying them back to their subterranean homes. But they do not eat the leaves directly. Instead, they mulch them carefully and feed them to cultivated fungi, which flourish in the humid chambers of the nest. This fungus becomes the ant's primary food source. Over millions of years, ants and fungi have co-evolved into complete dependence. The fungi cannot survive without the ants, and the ants cannot survive without the fungi. Even more astonishing, the ants employ symbiotic bacteria that live on their bodies to secrete antibiotics, protecting their crops from pests. What humans accomplished only in the last 10,000 years, ants achieved tens of millions of years ago. In the soil beneath our feet lies an ancient agriculture we rarely notice. Leafcutter ant colonies can be as large as cities. A single leafcutter ant colony can number in the millions, sprawling through networks of underground chambers that stretch dozens of meters across. These colonies are not mere nests, but vast, pulsing cities, with highways of workers streaming back and forth, carrying greenery like living flags. The underground structure is divided into specialized chambers, nurseries for larvae, vaults for the queen, and vast halls where fungi are cultivated. The queen herself may live for 2 decades, laying eggs that keep the society thriving. Communication flows through pheromones, scent trails that act like public announcements, directing labor with remarkable precision. When scientists map these colonies, they resemble human cities complete with divisions of labor, waste management, and resource distribution. But here, the architects are blind workers, guided only by instinct. It is a humbling realization. Beneath the soil, beings no bigger than fingernails construct societies that rival our own in organization and scale. Termites build mounds with natural air conditioning. In the hop savannas of Africa and Australia, termite mounds rise like earthen cathedrals, some towering more than 6 meters high. Inside live millions of termites, carefully tending to their colony and farming fungi for food. What is most remarkable, however, is that these mounds regulate their internal climate with extraordinary precision. Despite blistering heat by day and cold nights, the interior stays remarkably stable. The structure acts like a lung, with chimneys, vents, and porous walls that allow air to circulate and temperatures to balance. Termites continuously adjust the mound, repairing, widening, or narrowing passages as conditions shift. Their engineering has inspired architects seeking sustainable cooling systems for human buildings. Imagine standing beside one of these structures, a towering, breathing skyscraper of clay, built grain by grain, housing a society that relies on natural architecture more advanced than much of what humans design. Today, bioluminescent creatures light up the deep ocean. The deep ocean, a world of blackness beyond the reach of sunlight, is alive with light of its own. Here, countless organisms produce bioluminescence, glowing with hues of blue, green, and sometimes red. Tiny plankton sparkle like drifting stars, while fish trail shimmering lures to attract prey. Jellyfish pulse with neon patterns, some turning themselves into living fireworks to confuse predators. In these depths, light is a tool, a way to hunt, hide, mate, and communicate. Some creatures glow constantly, while others flash in bursts so sudden they seem like explosions in the dark. For sailors throughout history, glowing seas sparked wonder and fear. But to the animals who live here, this radiance is language, survival, and sometimes art. The ocean's darkest regions are, in truth, its most dazzling, a place where the absence of sunlight gave birth to light of an entirely different kind. Fireflies synchronize their flashes across entire forests. On humid nights in places like Southeast Asia or the Great Smoky Mountains, fireflies transform the darkness into a living light show. At first, their flashes seem random. But then, almost magically, entire populations begin pulsing in synchrony, thousands of tiny lanterns blinking together in rhythm, like the heartbeat of a forest. The synchronization happens naturally, each firefly adjusting to its neighbors until the pattern spreads across the trees. Scientists believe this coordination helps them attract mates more effectively, but to human eyes, it feels like a miracle. Imagine walking through the forest as the air pulses with waves of golden light, rising and falling as though nature itself is breathing. In these moments, insects the size of grains of rice create spectacles rivaling the grandest human fireworks, and they do it not once a year, but night after night, as part of their timeless dance. Some squid can turn invisible. Squid are masters of disguise, their skin packed with specialized cells that can shift color, reflect light, or even scatter it like glass. With chromatophores, iridophores, and leucophores working in harmony, squid can change patterns in an instant, stripes, ripples, or camouflage blending perfectly into sand or open water. Some species, however, can go further, rendering themselves nearly invisible. By scattering light in just the right way, they dissolve into the shimmering water around them, their outlines erased. Others become translucent, their organs faintly visible while the rest of their bodies vanish into the ocean. In the open sea, where there are few places to hide, invisibility is an unmatched defense. It also serves as a hunting tool, allowing squid to approach unsuspecting prey like ghosts. Invisibility, a dream of science fiction, is alive and perfected in these strange, intelligent cephalopods of the deep. Certain sharks glow in the dark. Sharks are ancient predators, but some are also lantern bearers of the sea. Lantern sharks, for instance, glow with a bioluminescent shimmer, casting soft green or blue light along their undersides. This glow acts as camouflage, blending them into faint light filtering down from the surface, making them invisible to predators below. Other glowing sharks use their light for communication, signaling potential mates or rivals in the dark. The glow comes from special light-producing organs called photophores, scattered across their bodies like living constellations. In the twilight zone of the ocean, these sharks drift like stars that swim. To imagine a predator glowing softly in the abyss is to see the ocean as both eerie and enchanting. It is not a barren darkness, but a theater of light, where even hunters carry lanterns, and survival itself becomes luminous. The Greenland shark can live for more than 400 years. In the icy waters of the North Atlantic swims one of the most mysterious animals on Earth, the Greenland shark. These enormous creatures glide slowly through the deep, often blind from parasitic worms that cling to their eyes, yet living lives of incredible duration. Radiocarbon dating of their eye tissues has revealed individuals more than 4 centuries old, making them the longest-lived vertebrates known. Some were alive before Shakespeare wrote his plays, before telescopes revealed the stars, before empires rose and fell. Greenland sharks grow slowly, sometimes less than a centimeter per year, and may not reach maturity until they are well over a century old. Their sluggish pace and cold habitat seem to shield them from the wear of time. To imagine a creature silently moving through dark waters for centuries is to realize how differently time flows for other beings sharing this planet with us. Some fish can survive without oxygen for weeks. For most animals, the absence of oxygen means swift death. But in certain ponds and rivers, where ice seals the surface in winter and oxygen levels plummet, some fish perform feats of endurance beyond belief. Goldfish and their wild relatives, crucian carp, can survive weeks without oxygen by switching their metabolism into an unusual gear. Instead of producing deadly lactic acid as humans do when deprived of air, they create ethanol, essentially alcohol, which they release harmlessly into the water around them. This biochemical trick allows them to wait out long, suffocating winters in safety, awakening when the thaw returns. It is not a comfortable existence, but it is survival, one of the most astonishing metabolic hacks in nature. While we gasp for air after only minutes, these fish endure timeless stillness, showing that life can bend its rules when the environment demands it. The lungfish can hibernate in mud for years. When drought grips the land and rivers dry to cracked clay, many fish perish. But not the lungfish. This ancient survivor, a living fossil with both gills and lungs, has learned to wait. As the waters retreat, the lungfish burrows into the mud, secreting a slimy cocoon that hardens around its body. Inside, it slows its metabolism to a whisper, breathing with its lungs in tiny, measured sips. It can remain like this for months, even years, until rains return and rivers swell again. Then, with astonishing patience, it wriggles free, emerging as though nothing had happened. This suspended animation is called estivation, and it allows lungfish to endure extremes that would kill nearly any other vertebrate. Their strategy is not to fight the drought, but to sleep through it, trusting in the return of water, a lesson in persistence written into their very bones. Some eels travel thousands of kilometers to spawn. For centuries, the lives of eels were a mystery. Aristotle once wondered where they came from, unable to find evidence of reproduction. We now know that eels undertake one of the most remarkable migrations on Earth. European and American eels spend most of their lives in rivers and lakes, growing for decades. Then, when it is time to reproduce, they begin an extraordinary journey, thousands of kilometers to the Sargasso Sea, a region of the Atlantic filled with drifting seaweed. There, in the open ocean, they spawn and die. Their offspring, tiny, transparent larvae shaped like willow leaves, drift back across the ocean on currents, eventually transforming into young eels that return to rivers their parents never saw. It is a cycle so improbable, so secretive, that even today, scientists still struggle to observe it fully. The eel's life remains one of the ocean's deepest mysteries. Parrotfish sleep in cocoons of mucus. Beneath coral reefs, when night falls, parrotfish prepare for sleep. But instead of simply tucking into a crevice, they secrete a protective cocoon of mucus, enveloping themselves in a transparent bubble. This slimy sleeping bag masks their scent from predators like moray eels, making them harder to detect. It also may act as a shield against parasites. Watching a parrotfish nestled within its own shimmering bubble is both strange and magical, like seeing a creature wrapped in a ghostly veil. By morning, the fish breaks free, ready to spend the day crunching coral with its beak-like jaws, creating the very sand that forms tropical beaches. Each night, this cycle repeats, a bed spun from mucus, a fragile barrier against the dangers of darkness. In this small, ingenious ritual lies a reminder that even sleep in the wild is never simple, but an act of survival. Seahorses give birth through the males. In the underwater world of seahorses, traditional roles are reversed. While males of most species compete for the chance to fertilize eggs, male seahorses do something different. They carry the young. After courtship dances and delicate displays, the female deposits her eggs into a specialized pouch on the male's body. There, he fertilizes them and provides oxygen and nutrients as they develop. Weeks later, he goes into labor, releasing fully formed miniature seahorses into the sea. This unique arrangement frees females to produce more eggs, while the males take on the nurturing role. Watching a male seahorse give birth, writhing as dozens of tiny replicas burst into the water, is both surreal and profoundly moving. It shows us that gender roles in nature are fluid, and that parenting can take forms as diverse as life itself. In the seahorse, we glimpse an oceanic inversion of our expectations. Some insects can walk on water. Water striders, delicate insects with long, spindly legs, glide across ponds and streams as though skating on glass. Their secret lies in physics. Tiny hairs on their legs repel water, trapping a layer of air that prevents them from breaking the surface tension. With each stride, they push against the dimpled water beneath them, using it like an invisible trampoline. Entire colonies of striders can gather, moving in synchrony like dancers across a mirrored stage. For them, the surface is not a barrier, but a world of its own, offering food and freedom from aquatic predators below. To us, walking on water is a miracle to these insects. It is simply daily life, perfected over millions of years. Watching them glide effortlessly across still ponds feels like a glimpse into another set of rules, one where the line between air and water becomes a playground. water bears can withstand deadly radiation. Tardigrades, tiny, plump creatures often nicknamed water bears, are among the most indestructible life forms we know. Beyond surviving the vacuum of space, they also endure radiation levels thousands of times higher than those fatal to humans. They achieve this by producing unique proteins that shield their DNA from damage and by entering a near-death state called cryptobiosis. In this state, their bodies dry out, their metabolism slows to almost nothing, and their cells are fortified against harm. Years later, they can revive with nothing more than a drop of water. Scientists study them closely, hoping to learn how their resilience might be applied to human health, radiation protection, or even long-duration space travel. Water bears, invisible to the naked eye, remind us that strength is not about size but about endurance, the ability to survive the impossible and awaken again. Some algae can survive inside rocks. In some of the harshest deserts on Earth, where blazing sun and desiccating winds make the surface unbearable, life has found a way to hide. Certain algae burrow into the porous interiors of rocks, living within translucent mineral layers that shield them from the elements. These endolithic organisms survive on the faint trickle of light that penetrates stone and the sparse moisture that seeps through microscopic cracks. It is a precarious existence, yet it allows them to endure in places where almost nothing else survives. Scientists have discovered them in Antarctica's dry valleys and in the Atacama Desert, environments so extreme they are used as analogues for Mars. These hidden algae whisper that life does not need abundance, it needs only possibility. To live inside stone is to defy expectations of where life can thrive, expanding our imagination of what worlds beyond Earth might harbor. Lichens are partnerships between algae and fungi. At first glance, lichens look like simple patches of crust or moss clinging to rocks and trees. But they are not single organisms at all. They are intricate partnerships between fungi and algae, or sometimes cyanobacteria. The fungus provides shelter, structure, and access to minerals, while the algae contribute photosynthesis, capturing energy from sunlight. Together, they form a composite being greater than the sum of its parts. Lichens can colonize bare stone, ice, and even rooftops, slowly breaking down surfaces and paving the way for other life. They endure in environments from frozen tundra to scorching deserts, surviving extremes that kill most plants. Some lichens are thought to live for thousands of years. Their quiet persistence teaches us about cooperation, two very different forms of life joining into one, proving that survival sometimes depends not on competition, but on partnership, a lesson as old as the breeze. Earth itself. Certain bacteria breathe metal instead of oxygen. For most life on Earth, oxygen is the final step in breathing, the molecule that accepts electrons and allows energy to flow. But some bacteria live in environments where oxygen never reaches. In deep mud, caves, or underground aquifers, they use metals instead. Iron, manganese, even uranium can serve as substitutes for oxygen, with the bacteria exhaling them as part of their metabolism. These organisms form rust-like coatings on rocks or transform metals into new chemical states, subtly reshaping their environments. Their ability hints at the ancient past, when oxygen was scarce and other elements carried life's chemistry forward. It also suggests possibilities for life on alien worlds, where oxygen may not exist at all. To imagine creatures that breathe metal is to see how flexible and inventive life can be, transforming what seems inert and lifeless into fuel for its own persistence. Some microbes can digest plastic. Plastic, humanity's most enduring invention, has spread to every corner of Earth. It clogs oceans, litters soils, and resists decay for centuries. Yet even this synthetic material has not escaped life's grasp. In recent years, scientists have discovered microbes capable of breaking down certain plastics, feeding on them as a source of energy. One bacterium, Ideonella sacchayensis, produces enzymes that dismantle polyethylene terephthalate, the material used in bottles and packaging. Fungi, too, have shown the ability to digest plastics in laboratory experiments. Though slow and imperfect, these abilities hint at life's astonishing adaptability. In just a few decades, organisms are already evolving to take advantage of a substance that never existed in nature before. It is a sobering reminder of the scale of human impact, but also a testament to life's relentless drive to make use of whatever environment or challenge it encounters. Trees communicate through underground fungal networks. Beneath the forest floor lies a hidden web, threads of fungi weaving through soil, linking tree roots into vast networks. Through these underground connections, trees share nutrients, sending sugars, nitrogen, and phosphorus to one another. They even transmit chemical signals, warning of insect attacks or drought. Older, larger trees, sometimes called mother trees, nourish younger seedlings through these networks, ensuring the survival of the next generation. Scientists have nicknamed this vast system the Wood Wide Web, a quiet communication channel that binds the forest together. Though trees appear silent and separate above ground, below they are joined in constant exchange, a community rather than individuals. To walk through a forest, knowing this is to see differently. Every trunk is a tower connected by hidden threads, a conversation of roots and fungi that has been ongoing for millions of years. Plants can release chemical warnings to neighbors. Plants, though rooted and still, are far from passive. When insects begin chewing on their leaves, some plants release chemical signals into the air. These volatile compounds drift to nearby plants of the same species, triggering them to prepare defenses, producing bitter chemicals, toughening their tissues, or even attracting predators of the insects. In this way, plants warn each other of approaching threats. Some even change the taste of their leaves so dramatically that herbivores abandon them for less prepared meals. To human senses, these warnings are invisible, carried as faint perfumes or odors we may never notice. But within the silent battlefields of fields and forests, they are cries of alarm, invisible messages drifting on the wind. Plants, it turns out, are not mute observers of their fate. They are active participants in survival, communicating through a language written in scent and chemistry. The Venus flytrap can count its prey's movements. The Venus flytrap is one of nature's most iconic predators, a plant that snaps shut on unsuspecting insects. But it does not waste energy on false alarms. Inside each trap are tiny trigger hairs. A single touch is ignored. But if a second touch follows within about 20 seconds, the trap closes, sealing the prey inside. The plant is, in effect, counting. Once shut, further touches stimulate the plant to secrete digestive enzymes, breaking down the insect into nutrients. This counting mechanism ensures that the plant only invests energy when a true meal is caught. It is a sophisticated behavior for something without nerves or a brain. Watching a Venus flytrap in action is like seeing intelligence expressed in green, a patient hunter lying in wait, timing its response with silent precision, turning stillness into strategy in the most surprising way. Some plants remember past experiences. Memory is something we often associate with animals, but certain plants appear to remember as well. In experiments, the sensitive plant Mimosa pudica, which folds its leaves when touched, was repeatedly dropped in a harmless way. At first, the leaves snapped shut in defense, but over time, the plant stopped reacting, as if it had learned that the stimulus was not dangerous. Weeks later, the plant still remembered, ignoring the harmless drops while responding to new threats. This form of memory does not involve neurons, but biochemical changes within cells, altering how they respond to stimuli. It shows that even organisms without brains can retain information from the past and adjust their behavior in the future. Plants may be rooted in place, but they are not without awareness. In their own way, they record experience, learning from the world that shapes them. Bamboo can grow nearly a meter in a single day. Among the fastest growing plants on Earth, bamboo has an almost magical pace. In ideal conditions, certain species can stretch nearly a meter in a single day, so quickly that attentive observers swear they can see it rising. Its hollow stems, divided into segments, allow nutrients and water to surge upward efficiently, fueling this explosive growth. For centuries, bamboo has been a resource for humans, providing food, shelter, tools, and even musical instruments. But its speed also makes it a symbol of resilience and renewal in many cultures. While forests of trees take decades to mature, bamboo can regenerate after harvest within a season. In regions where it grows, it is both a building material and a living metaphor. Strength through flexibility, power through patience, speed through design. Bamboo's growth is not only extraordinary, but deeply poetic, embodying nature's ability to flourish with breathtaking swiftness. The Titan arum produces the world's largest flower. Deep in the rainforests of Sumatra grows a plant with a bloom that has astonished explorers and botanists alike, the Titan arum, sometimes called the quartz flower. When it blossoms, which happens rarely, a single flower stalk can reach over 3 meters tall, towering like a spire. The bloom opens to reveal a deep crimson interior and releases a stench reminiscent of rotting meat. The foul odor attracts carrion beetles and flies, which pollinate the plant as they search in vain for food. For the brief time the flower is open, it becomes a spectacle of both beauty and grotesquerie, one of the largest and strangest blooms in the natural world. Crowds often gather at botanical gardens when Titan arums flower, drawn by curiosity and wonder. In its fleeting, monumental bloom, the Titan arum captures the drama of life itself, brief, bold, and unforgettable. Some orchids trick insects by imitating female scents. Orchids are masters of deception. Some species have evolved to lure male insects by mimicking the appearance and scent of females. Their petals take on shapes that resemble insect bodies, while chemical compounds on their surfaces release pheromone-like fragrances. Male insects, fooled by the imitation, attempt to mate with the flower, brushing against its pollen in the process. When they move on to the next orchid, they carry the pollen with them, unwittingly completing the plant's reproductive cycle. It is a strategy that borders on trickery, a biological illusion crafted to perfection. To us, the orchid is a thing of beauty. To an insect, it is a fleeting promise, irresistible yet false. In these delicate blooms, evolution reveals its cunning, survival achieved not by force, but by artifice, persuasion, and the subtle power of seduction. The corpse flower smells like rotting flesh to attract pollinators. Few natural encounters are as striking as standing near a blooming corpse flower. Native to the rainforests of Sumatra, this giant bloom emits an odor so strong and foul, it can be detected from hundreds of meters away. To humans, it smells like decay, a nauseating stench of spoiled meat. But to beetles and flies that feed on carrion, it is an irresistible lure. They crawl deep into the flower's cavernous structure, carrying pollen as they move between blooms. The strategy works. By mimicking death, the plant ensures its life continues. For the brief days of its flowering, the corpse flower becomes a spectacle, both repulsive and mesmerizing, drawing crowds eager to see and smell the marvel. In its grotesque beauty lies a lesson. Survival can take many forms, and even revulsion can be transformed into a tool for reproduction. Some seeds can survive dormant for thousands of years. Seeds are nature's time capsules. Encased in protective shells, they carry the blueprint of future life and wait patiently for the right conditions to awaken. Some seeds can bide their time not just for years, but for millennia. In Siberia, scientists revived a flowering plant from a seed buried in permafrost for over 30,000 years. In the Judean desert, a 2,000-year-old date palm seed was coaxed back to life, sprouting leaves that reached toward the modern sun. This endurance comes from a remarkable ability to shut down metabolism almost entirely, preserving delicate tissues against the slow march of time. Seeds may appear lifeless as they sit buried in the soil or tucked away in ancient ruins, but within them is a spark of potential waiting across centuries. To hold such a seed in your hand is to feel the patience of nature, carrying tomorrow's forests in silent sleep. Mangrove trees can filter salt from seawater. Along tropical coastlines where the sea meets the land, mangrove forests stand with roots tangled like knotted webs. These trees thrive where most plants cannot, in salty, brackish waters. To survive, mangroves have evolved extraordinary adaptations. Some species filter salt directly from the water at the root level, drawing up only fresh water for themselves. Others excrete salt through specialized glands on their leaves, leaving behind crusty white residues. Their arching roots not only stabilize the trees, but also provide nurseries for fish, crabs, and countless other species. Mangroves protect coastlines from erosion and storms, acting like living barriers between land and sea. They are guardians of the shore, thriving where fresh and salt water mix. Each tree is both an engineer and a protector, proof that survival in harsh environments often comes not from resistance, but from adaptation and quiet resilience. Some grasses can survive wildfires by sprouting underground. Wildfires sweep across landscapes with terrifying speed, reducing forests and fields to ash. Yet when the smoke clears, life often rises again, especially from the grasses. Unlike many plants that die when flames consume their leaves, certain grasses store their life underground in hardy organs called rhizomes or bulbs. Even when fire scorches the surface, these hidden parts remain protected, waiting to sprout fresh green blades. Within weeks, blackened ground can glow again with tender shoots, feeding grazers and rebuilding ecosystems. In fact, many grasslands depend on periodic fires to renew themselves, clearing dead material and fertilizing the soil with ash. Fire, which appears destructive, is part of their cycle of rebirth. Watching a prairie return to life after fire is to witness resilience made visible, proof that destruction and renewal are often two sides of the same natural rhythm. Coral reefs are built by tiny animals but support entire ecosystems. When we imagine coral reefs, we see sprawling underwater cities full of fish, turtles, and glowing colors. Yet reefs are built by some of the smallest creatures of the sea. Coral polyps, tiny animals related to jellyfish. Each polyp secretes calcium carbonate, slowly forming the hard skeletons that pile up into reefs over thousands of years. Though small and fragile individually, together they create structures visible from space. These reefs shelter a quarter of all marine life, providing food, homes, and breeding grounds. They also protect coastlines from waves and storms, acting as living barriers. Without corals, tropical seas would be barren. Their quiet labor builds kingdoms of beauty and biodiversity, fragile yet vital. To swim among them is to move through a cathedral not of stone but of life, built by countless small beings working together across centuries. Clownfish live in symbiosis with stinging anemones. Among the vibrant homes of coral reefs, clownfish live nestled within the tentacles of sea anemones, a place deadly to most creatures. Anemones wield stinging cells that paralyze fish on contact, but clownfish are coated in a special mucus that protects them. This unique adaptation allows them to hide safely in the anemone's embrace, immune to its venom. In return, clownfish provide benefits to their hosts. They chase away predators, clean debris, and stir the water to help the anemone breathe. The partnership is so close that the fish rarely stray far from their living fortress. Watching them dart among the waving tentacles, bright orange against the swaying white or purple arms, it's easy to see why they've captured human imagination. The relationship is a delicate balance of danger and protection, a mutual trust between two species that makes survival possible. Cleaner fish run stations where other fish line up. On reefs, some fish perform an unexpected role, barbers and doctors to their neighbors. Cleaner fish, such as wrasses, establish cleaning stations where larger fish, even predators, gather peacefully. Instead of hunting, the big fish wait their turn as the cleaners dart over their bodies, nibbling away parasites, dead skin and debris. Groupers, eels, and parrotfish all submit, sometimes opening their mouths wide so cleaners can swim inside and tidy their gills. This behavior benefits both sides. The cleaners gain steady food, and their clients enjoy relief from pests. Watching a reef cleaning station is like observing a marketplace or a spa, with species that might otherwise be enemies coexisting in cooperation. It shows that even in nature's competitive world, mutualism can flourish, moments of peace where survival depends not on conflict, but on collaboration and trust. Some sharks never stop swimming. For many shark species, swimming is not just movement, but survival. Without it, they would suffocate. Unlike fish that can pump water over their gills while resting, certain sharks rely on constant forward motion to force oxygen-rich water through their gills. These obligate ram ventilators, such as great white sharks and mako sharks, are always in motion, day and night. To sleep, they shut down parts of their brain while their bodies keep swimming, a drifting half-dream of perpetual motion. This constant journeying gives them a mysterious presence, forever on the move, never truly still. Watching footage of such sharks gliding endlessly through the water, one feels their alien rhythm, creatures built not for rest, but for ceaseless wandering. For them, the ocean is both bed and highway, a place where life is sustained only by unbroken momentum. Sea turtles use the moon and stars to find the ocean. On warm beaches, newborn sea turtles dig free from their nests and begin a desperate crawl toward the sea. Guided by instinct, they orient themselves toward the brightest horizon, usually the moonlight and starlight glinting off the waves. This ancient navigation system has served them for millions of years, directing tiny hatchlings to the vast ocean. As adults, sea turtles navigate even greater distances, crossing entire oceans to return to the very beaches where they were born. How they achieve such precision remains partly a mystery, though magnetic fields and celestial cues both play roles. To imagine a creature navigating by the shimmer of stars is to glimpse a navigation older than maps, older than compasses, a reliance on the sky itself. Their journeys remind us that even the smallest spark of light can guide us across immense darkness. Penguins can drink salt water safely. In the icy seas where penguins live, fresh water is often scarce. Yet they thrive, diving and swimming for hours without issue. Their secret lies in specialized glands above their eyes that filter salt from their blood. After drinking seawater or swallowing briny fish, these glands excrete the salt as concentrated droplets, which drip from their beaks, or are sneezed out in tiny sprays. This adaptation allows penguins to survive in environments where humans would quickly dehydrate. It frees them to live fully in the marine world without dependence on rivers or rain. Watching a penguin shake its head, scattering a fine mist of salt water, is to see a subtle miracle of physiology. In their tuxedoed bodies lies a design perfectly tuned to ice and ocean, a bird that turned the sea itself into its endless drinking fountain. Some birds sleep while flying. High above oceans where land is distant and rest is impossible, some birds have learned to sleep on the wing. The great frigate bird, for instance, spends weeks aloft without landing, gliding on warm currents. Researchers have discovered that while flying, these birds shut down one half of their brain at a time, resting while the other half remains alert enough to steer. These micronaps may last only seconds, but taken repeatedly, they allow the bird to survive long journeys without touching ground. It is a breathtaking adaptation, to dream while in motion, to rest without stopping. Imagine drifting through the sky, eyes half closed, carried by invisible winds, suspended between wakefulness and sleep. For birds that live at the edge of endurance, sleep itself has become as flexible and creative as their flight. Albatrosses can glide for hours without flapping. Albatrosses are masters of the wind, spending most of their lives soaring over vast oceans. Their wings, stretching up to 3.5 meters, are perfectly adapted for a technique called dynamic soaring. By skillfully angling into wind currents, they rise and fall in great arcs, extracting energy from the invisible waves of air above the sea. This allows them to glide for hours, sometimes days, without a single flap. With this gift, albatrosses can circle the globe with ease, traveling tens of thousands of kilometers each year. They sleep on the wing, drink rainwater caught in their beaks, and only come to land to breed. To see an albatross floating endlessly above the waves is to witness a creature at one with the air itself, riding winds as though the entire sky were an endless road. Hummingbirds' hearts beat over 1,000 times a minute. Tiny and radiant, hummingbirds are among the most astonishing athletes in nature. Their wings blur faster than the eye can follow, allowing them to hover in place and dart in any direction. To fuel this feat, their hearts beat at astonishing speeds, more than 1,000 times per minute in flight. Their metabolism is so rapid that they must drink nectar almost constantly, visiting hundreds of flowers each day. At night, to conserve energy, they enter a state called torpor, slowing their heart rates dramatically, as if slipping into mini-hibernation. Hummingbirds are proof of nature's extremes. Creatures so delicate they weigh less than a penny, yet so powerful they can migrate across the Gulf of Mexico in a single non-stop flight. In their tiny, jewel-like bodies beats a rhythm as fast and fiery as life itself can burn. Some birds dance elaborately to court mates. Courtship in the animal world takes many forms, but in certain birds, it becomes an art form. Birds of paradise, for example, perform dances of breathtaking complexity. Males clear display areas on the forest floor, then hop, sway, and unfurl feathers into dazzling shapes of color and light. Some species even transform their appearance entirely, spreading wings and tails to create symmetrical patterns, their bodies becoming living kaleidoscopes. Female birds watch closely, choosing mates based on the precision and creativity of these displays. Elsewhere, grebes perform elegant synchronized dances on water, running across the surface side by side in perfect unison. These rituals are more than instinct. They are performances honed by evolution, each movement a declaration of vitality and charm. To watch such displays is to glimpse courtship elevated into theater, survival expressed as beauty, rhythm, and grace. Lyrebirds can mimic chainsaws and car alarms. Deep in the forests of Australia lives the lyrebird, a master of mimicry unlike any other. Its tail feathers, shaped like a lyre, are a visual marvel, but its true gift is its voice. Lyrebirds can imitate almost any sound they hear, from the calls of other birds to the creak of branches, the shutter of cameras, even the harsh buzz of chainsaws and the shriek of car alarms. Males weave these imitations into elaborate songs to impress females, layering natural and artificial sounds into an uncanny symphony. Standing in a forest and hearing a lyrebird call is like listening to the environment itself echo back in unexpected ways. Their mimicry is so precise it can fool the ear completely. In the lyrebird, nature created not just a singer, but an impressionist, a performer capable of replaying the modern world through the ancient voice of the wild. The Arctic tern migrates from pole to pole each year. The Arctic tern is a traveler without equal. Each year, it journeys from its breeding grounds in the Arctic all the way to Antarctica, then back again, a round trip of more than 70,000 kilometers. This means the tern experiences 2 summers every year, chasing endless daylight across the globe. Over its lifetime, a single bird may fly the equivalent distance of 3 trips to the moon and back. Despite its delicate appearance, the tern endures storms, oceans, and endless stretches of sky. Guided by instincts scientists are only beginning to understand. It is a creature defined by motion, an endless cycle of light and distance. To imagine such a tiny bird tracing vast arcs across the Earth is to realize that migration is not just survival, but a form of cosmic dance, a life written on the map of the planet itself. Some spiders use silk as parachutes to travel the sky. When young spiders hatch, they often face the need to disperse far from their crowded birthplace. Their solution is ingenious. They climb to a high point, raise their bodies, and release threads of silk that catch in the wind. With this ballooning behavior, they drift like living parachutes, carried by breezes across fields, forests, and sometimes oceans. Some spiders have been found thousands of meters high in the atmosphere, floating unseen among the clouds. Others land on ships far from shore, having crossed vast seas as stowaways on invisible air currents. Watching a spider lift gently into the air, borne upward by strands of gossamer, is to witness the improbable beauty of flight without wings. It reminds us that the sky is not empty, but filled with travelers smaller than the eye, carried silently on threads of silk into the unknown. Orb-weaver spiders can spin silk stronger than steel. Among the most beautiful engineers of the animal kingdom are orb-weaver spiders, whose symmetrical webs glisten in morning dew. The silk they produce is one of nature's most remarkable materials, lighter than cotton, yet stronger, gram for gram, than steel. It stretches without breaking, absorbing impacts that would shatter other fibers. To produce a web, the spider uses multiple types of silk, each specialized for a different function. Strong radial threads, sticky spirals for trapping prey, and soft silk for wrapping and protection. Despite their fragility, orb-weaver webs can catch insects many times the spider's size. Human scientists have long sought to replicate spider silk, hoping to use it in medicine, engineering, and textiles, but its complexity remains elusive. The spider, with its delicate legs and patient weaving, accomplishes nightly what our most advanced technology has yet to master. Trapdoor spiders build hinged homes underground. In the quiet earth beneath grass and leaf litter, trapdoor spiders construct hidden homes. They dig burrows lined with silk, then craft camouflaged doors of soil and plant matter, hinged with spider silk to swing silently open and shut. From inside, the spider waits motionless, sensing vibrations of the entrance. When unsuspecting prey approaches, the door bursts open, and the spider seizes its victim before retreating back inside. The door then swings shut again, leaving no trace of the ambush. These ingenious homes keep the spiders safe from predators and weather while providing the perfect vantage for hunting. Unlike the airy webs of orb weavers, trapdoor spiders' creations are fortresses of patience, designed for secrecy. To pass by such a burrow is to be unaware of the drama that lies just beneath the soil, a world of hinges, shadows, and sudden strikes. Some wasps turn other insects into zombies. Among nature's most unsettling strategies are the parasitic wasps that manipulate other creatures into serving as unwilling hosts. Some species inject their eggs into caterpillars or cockroaches. When the larvae hatch, they feed inside the living body, releasing chemicals that alter their host's behavior. One wasp forces a cockroach into docility, baiting it like a puppet to a burrow where it becomes a larder for the developing young. Another compels a caterpillar to guard the wasp pupae, sacrificing its own survival in the process. These behaviors seem almost like science fiction, yet they are real examples of how evolution can shape even the minds of prey. The victim becomes neither fully alive nor fully dead, but an instrument of another's survival. To contemplate such strategies is to glimpse nature's darker genius. Adaptations as eerie as they are effective. Honeybees perform dances to communicate locations. Inside the buzzing hive, honeybees share information not with words, but with dance. When a forager discovers a rich patch of flowers, she returns and performs the waggle dance, a looping pattern that encodes the distance and direction of the food relative to the sun. Other bees watch closely, interpreting the movements with remarkable accuracy, then fly straight to the flowers described. This communication system allows hives to exploit resources efficiently, coordinating thousands of individuals into a collective intelligence. The waggle dance is not only precise but adaptable, changing as the sun moves across the sky. Watching bees spin in rhythmic circles while their sisters listen is to witness a society bound by movement and vibration, a language as old as flowers themselves. In their dances lies both survival and beauty, a choreography written by evolution and performed in every hive. Some frogs carry tadpoles on their backs. In the rainforests of Central and South America, certain frogs take on the role of guardians in a way that feels almost tender. The male strawberry poison dart frog, for example, watches over freshly hatched tadpoles. One by one, he gently carries them on his back, climbing from the forest floor up towering plants and trees. Each tadpole is placed into a tiny pool of water, often the hollow of a leaf or a pocket in a bromeliad. The mother then returns regularly to feed them with unfertilized eggs, a selfless offering that sustains their growth. These rituals show a level of parental care unusual among amphibians. Instead of leaving offspring to chance, these frogs ensure each new life has a safe start. Watching a frog hop patiently through the forest with a wiggling tadpole on its back is to glimpse a quiet, devoted side of survival. The Suriname toad gives birth through holes in its skin. Among the strangest birth stories in nature is that of the Suriname toad. After mating, the female's back becomes soft and spongy, and the male presses fertilized eggs into it. The skin then grows around the eggs, sealing them into honeycomb-like chambers. There they develop, safe beneath the mother's skin. Weeks later, tiny, fully formed toads emerge directly from her back, bursting through like living jewels released from pockets of flesh. Though unsettling to watch, this method protects offspring from predators and harsh environments, ensuring more survive. It is a vivid reminder that life invents strategies as diverse as imagination itself. In the Suriname toad, motherhood takes a form unlike any other, transforming skin into shelter, back into nursery. What seems bizarre to us is, to this species, simply the way of life, an extraordinary adaptation written into their ancient lineage. Glass frogs have transparent bodies. In the cloud forests of Central and South America, tiny frogs rest on leaves, going green and delicate. When you look closely, you discover something extraordinary. Their skin and muscles are translucent. In many species of glass frog, the entire belly is see-through, revealing the beating heart, winding intestines, and even developing eggs. Scientists believe this transparency may help them avoid predators, blending with the dappled light filtering through leaves. When they cling to the underside of foliage, their bodies vanish almost entirely into the green background. Their delicate beauty is otherworldly, as though they are living windows into anatomy itself. To see a glass frog is to confront the fragility of life laid bare, organs pulsing in plain sight, yet perfectly protected by nothing more than a thin veil of living glass. Some lizards can shoot blood from their eyes. In the deserts of North America lives the horned lizard, a spiky reptile with a startling defense. When threatened by predators such as coyotes, it can squirt jets of blood from the corners of its eyes, shooting up to several feet. The blood is laced with chemicals that taste foul to attackers, discouraging further pursuit. This defense is not used lightly. The lizard must build pressure in its sinuses until blood bursts forth, leaving it temporarily disoriented. Yet it works, turning a small, slow-moving reptile into something predators think twice about eating. Combined with its camouflage and spiny armor, the horned lizard's blood-squirting ability is one of the most unusual survival tricks in the animal kingdom. It reminds us that nature's strategies are not always elegant, but they are effective, a vivid display of shock and ingenuity etched into the desert sands. The basilisk lizard can run across water. Nicknamed the Jesus Christ lizard, the basilisk of Central America performs a feat that seems miraculous. It runs across the surface of water. Using its powerful hind legs, fringed with specialized scales, it slaps the water hard enough to create pockets of air. By moving quickly, it prevents itself from sinking, skimming across rivers and ponds for several meters before finally diving under. Juvenile basilisks, being lighter, can run farther than adults, but even large individuals can dash across the surface to escape predators. To see one sprint across a stream is to feel disbelief turn into wonder, as though gravity itself had briefly loosened its grip. The basilisk's ability is not magic, but physics harnessed by evolution, yet in the shimmering light of a rainforest river, it feels like a glimpse of myth made real. Some snakes can glide through the air. High in the forests of Southeast Asia, certain snakes do the impossible. They fly. Paradise tree snakes flatten their bodies and launch themselves from branches, undulating in mid-air to control their glide. By shifting the shape of their ribs, they turn their bodies into living parachutes, generating lift as they move. Though they have no wings, they can travel more than 20 meters in a single leap, steering towards safe landings. To watch one of these snakes glide is to see contradiction embodied. A creature we think of as bound to the ground becomes a ribbon of life flowing through the air. Scientists study their flight to learn about aerodynamics, marveling at how something so unlikely can be so graceful. These snakes remind us that flight is not the domain of birds and bats alone. In the rainforest canopy, even serpents take to the skies. Komodo dragons have venomous bites. The Komodo dragon, the largest lizard on Earth, can grow more than 3 meters long and weigh over 70 kilograms. For decades, scientists believed its power lay in its sharp teeth and bacteria-filled saliva. But research has revealed another secret: venom. Komodo dragons possess venom glands that deliver toxins into their prey. These toxins thin the blood, lower blood pressure, and prevent clotting, sending victims into shock. Combined with the dragon's jagged bite, this venom makes their attacks devastating. Komodos use stealth and patience, ambushing prey as large as deer or water buffalo. Once bitten, even if the animal escapes, it often succumbs within hours. Then the dragon follows its scent trail to feed. Watching these massive reptiles move with slow, deliberate steps, it is easy to see echoes of ancient predators. In the Komodo dragon, evolution preserved a relic of a more primal world. Crocodiles can slow their hearts to survive long without food. Crocodiles are masters of endurance. With metabolisms far slower than ours, they can go weeks, even months, without eating. One secret lies in their remarkable control over their hearts. Crocodiles can slow their heartbeat to just a few beats per minute, conserving oxygen and energy while they lie motionless in water or buried in mud. This ability allows them to ambush prey with endless patience, waiting for the perfect moment to strike. In lean times, it lets them endure long stretches without meals, surviving where other predators might starve. Crocodiles are living fossils, their bodies honed by over 200 million years of evolution. Their slow, steady hearts echo with ancient rhythms, reminding us that survival is not always about speed or activity, but about stillness, efficiency, and an ability to wait. In their silence lies an almost timeless strength. Some fish use electricity to communicate. In murky waters where vision is limited, certain fish have evolved a language of electricity. Electric fish, such as knife fish and elephant nose fish, produce weak electric fields around their bodies. By modulating these signals, they can sense objects, navigate in darkness, and even talk to one another. Each fish has a unique electric pattern, allowing individuals to recognize mates and rivals. They exchange bursts, pulses, or waves like coded messages, filling the water with silent conversations. For us, electricity is a tool of civilization. For these fish, it is a sense as natural as sight or sound. Their lives reveal how many ways there are to perceive the world, and how alien yet familiar other senses can be. To imagine water filled with invisible electric chatter is to glimpse a dimension of life hidden from human experience. Electric eels can deliver shocks strong enough to stun horses. Despite their name, electric eels are not true eels, but knife fish. They are famous for their ability to generate powerful electric discharges, up to 600 volts, enough to knock a human off their feet, and strong enough, historically, to stun a horse. They use this electricity both for hunting and defense. A sudden jolt can paralyze prey, allowing the eel to swallow it whole. They can also produce weaker pulses to navigate and sense their environment in dark waters. Their bodies are essentially living batteries with specialized cells called electrocytes stacked like rows of capacitors. When activated, these cells discharge simultaneously, unleashing a shock of astonishing force. For indigenous peoples of the Amazon, where electric eels live, these creatures have long been both respected and feared. To encounter one is to feel the raw, untamed power of biology turned into lightning. Bioluminescent bacteria can make fish glow. In the ocean's twilight, light becomes both a weapon and a shield. Many deep-sea fish do not glow by themselves, but host colonies of bioluminescent bacteria in specialized organs. These bacteria emit a steady, living light, creating lanterns beneath the waves. Some fish use the glow as camouflage, blending with faint light from above, so predators below cannot see their silhouettes. Others wield it like a lure, attracting prey to their mouths. The relationship is symbiotic. The fish provide a safe home and nutrients, while the bacteria provide the light. The flashlight fish, for instance, carries glowing patches beneath its eyes that it can blink on and off, creating patterns in the darkness. To us, it is strange to imagine animals powered by colonies of microbes, yet in the deep, partnerships like this are common. Even in darkness, life finds ways to shine together. Some squid communicate through shifting colors. Squid are among the ocean's most expressive creatures, their skin alive with pigments and iridescence. Beneath their surface lie chromatophores, tiny sacs of color that expand and contract at lightning speed. With these, squid can flash patterns across their bodies, shifting from pale to deep crimson in a heartbeat. Scientists believe many species use this ability not just for camouflage, but for communication. Groups of squid often coordinate their colors, pulsing stripes or spots in synchrony, perhaps as signals of courtship, aggression, or cooperation. Imagine entire schools of squid flickering like living light shows, conversations carried out in flashes of color we cannot fully decipher. To humans, their displays seem alien, almost like neon signs rippling beneath the waves. But to squid, it is simply language, a silent dialogue written in living patterns across skin that never stops changing. The vampire squid lives in nearly oxygen-free depths. Despite its sinister name, the vampire squid is a fragile survivor of the deep. It lives in one of the harshest environments in the ocean, the oxygen minimum zone, where levels are so low that most creatures cannot survive. The vampire squid drifts slowly, conserving energy, with gelatinous skin and a cloak-like web connecting its arms. Unlike its relatives, it does not hunt actively. Instead, it gathers marine snow, drifting bits of organic matter, with sticky filaments, rolling them into food balls. Its name comes from its dark color and eerie appearance, but it feeds more like a gentle collector than a predator. In waters that seem unlivable, it has carved out a niche, a ghostly remnant of ancient cephalopods. The vampire squid proves that survival doesn't always mean strength or ferocity. Sometimes it means patience, efficiency, and mastering the art of living with very little. The colossal squid has eyes the size of dinner plates. In the dark depths of Antarctica's waters lives the colossal squid, a creature so rarely seen that only a handful have ever been captured. It grows to lengths rivaling those of giant squids, but it is even heavier, a true leviathan of the sea. Its most astonishing feature is its eyes, the largest of any known animal, up to 30 centimeters across, the size of a dinner plate. These enormous eyes allow it to detect faint glimmers of light in the abyss, such as the glow of bioluminescent prey or the shadow of approaching predators like sperm whales. To imagine looking into such an eye is to feel the immensity of the deep ocean staring back. Colossal squids remain mysterious, their lives largely hidden, but the size of their eyes alone tells us how profoundly dark and immense their world truly is. Some deep-sea fish have transparent heads. In the silent blackness of the deep sea drifts one of the strangest creatures on Earth, the barrel-eye fish. Its head is transparent, like a living glass dome, revealing its eyes glowing faint green inside. These eyes are not fixed forward but point upward, scanning the faint silhouettes of prey above while the fish hovers motionless. If needed, the eyes can rotate forward to track food as it approaches. This unusual design allows the barrel-eye to live with precision in near-total darkness, conserving energy while maintaining vigilance. The transparent shield of its head protects its delicate eyes from stings of siphonophores, gelatinous predators that dominate the deep. To see a barrel-eye fish is to glimpse something alien, a creature whose skull is not barrier but window, turning its inner workings into a strategy for survival. It is a reminder that in the deep, life rewrites the rules of form itself. The anglerfish uses a glowing lure to hunt. Few images of the deep ocean are as haunting as the anglerfish, with its jagged teeth and eerie lantern. On its head extends a fleshy stalk tipped with bioluminescent bacteria that glow like a living light bulb. In the perpetual night of the abyss, this lure shines irresistibly, drawing curious fish and squid closer. When they approach, the anglerfish snaps its jaws shut with lightning speed, swallowing prey nearly half its size. Females, much larger than males, carry these lures, while tiny males sometimes fuse permanently to their bodies, becoming little more than appendages providing sperm. This bizarre lifestyle seems more like fantasy than fact, yet it is the reality of deep-sea survival. In the darkness, light is life, and the anglerfish has weaponized it, turning a beacon of hope into a trap. Some crabs decorate themselves with living sponges. Camouflage in the ocean takes many forms, but some crabs take it to an art. Decorator crabs pluck bits of sponge, coral, and even living anemones, attaching them to hooked bristles on their shells. These decorations conceal their shapes, breaking their outlines into the background of the reef. Some choices are strategic. Anemones sting would-be predators, offering extra protection, while sponges can release toxins. The crab, in turn, gives the anemone mobility, carrying it to new hunting grounds. Watching a decorated crab move is like seeing a walking garden, a patch of reef come to life. What looks whimsical is actually survival strategy, a clever collaboration between creature and environment. In the ceaseless struggle of predator and prey, some crabs survive not by hiding away, but by turning themselves into living landscapes. Hermit crabs form vacancy chains to trade shells. Hermit crabs do not grow their own shells. They borrow empty ones from snails. But as they grow, they must trade up to larger homes. In the wild, this often leads to remarkable social behavior. When a new shell appears, multiple hermit crabs gather, inspecting it carefully. If it is too large, they form a line, from smallest to largest, each waiting for the crab ahead to move into the new shell so they can inherit the one just vacated. These vacancy chains can involve a dozen crabs or more, shuffling homes in a sequence of perfect timing. The cooperation ensures that everyone benefits, turning competition into a kind of community event. Watching crabs trade shells like tenants exchanging apartments is both amusing and profound. A glimpse of how even simple creatures can negotiate scarcity through patience and order. Some shrew can see more colors than humans. Our eyes, marvelous as they are, contain 3 types of color receptors, allowing us to see the spectrum of the rainbow. But the mantis shrimp, a small, flamboyantly colored marine predator, carries up to 16 types. This means it perceives the world in ways we cannot imagine, detecting ultraviolet and polarized light invisible to us. For the mantis shrimp, the reef is likely an explosion of signals, patterns, and hues hidden from human vision. These abilities help them in hunting and communication, as their shells shimmer with signals visible only to each other. To imagine what the world looks like to a mantis shrimp is impossible. It is a palette beyond our comprehension. They remind us that our vision is not the limit of reality, but just one version among many. The ocean is full of colors we will never truly see. The mantis shrimp punches with the force of a bullet. Beyond its incredible vision, the mantis shrimp possesses another superpower, one of the fastest strikes in the animal kingdom. Its club-like appendages accelerate with such speed that they create cavitation bubbles, tiny voids that collapse with bursts of heat and light. The strike is so powerful it can shatter aquarium glass and crack the shells of crabs and snails. To its prey, the punch lands with the force of a speeding bullet. Remarkably, the mantis shrimp can unleash these blows repeatedly without damaging its own limbs, thanks to a complex arrangement of spring-like structures and shock-absorbing tissues. To watch one hunt is to see raw physics in action, a creature harnessing mechanics with explosive precision. Despite their small size, mantis shrimp embody ferocity and brilliance, combining extraordinary perception with devastating power. They are tiny gladiators of the reef, hidden in plain sight. Some worms glow green in the ocean. In the twilight of the ocean, where daylight fades and darkness begins to reign, some worms glow with an otherworldly green light. These are polychaete worms, fragile creatures whose bodies shimmer with bioluminescence. When disturbed, they sometimes release glowing particles into the water, leaving behind streaks of emerald fire as they retreat. Scientists believe this light may confuse predators or attract mates. But for us, it is simply mesmerizing, threads of living light drifting through the sea. Unlike the fierce lanterns of anglerfish or the sudden flashes of squid, the glow of these worms feels delicate, almost like a quiet breath in the darkness. It is a reminder that even the smallest creatures, often overlooked, have found ways to turn survival into spectacle. In the ocean's endless blackness, they write their presence in light, brief but unforgettable. Others build chimneys of metal sulfides on the sea floor. On the ocean floor, in places where Earth's crust cracks open, hydrothermal vents spew out scalding water rich with minerals. Around these vents rise strange towers, chimneys built not by hands, but by chemistry. As hot water meets cold seawater, metals like iron and copper precipitate, forming tall, jagged structures that can reach several meters high. Some are called black smokers, releasing dark plumes of mineral-laden water. These chimneys are not lifeless rock, but the foundation for entire ecosystems. Tube worms, shrimp, and crabs gather in dense colonies, feeding on bacteria that thrive in the chemical-rich environment. To stand near one would be like gazing at an alien city, rising out of darkness, glowing faintly with heat. In a world without sunlight, these chimneys become life's skyscrapers, monuments to the strange chemistry that makes survival possible in Earth's most hostile places. Some animals can survive in boiling hot springs. In volcanic regions where hot springs bubble and steam rises from the ground, the water can reach near boiling temperatures. For most life, such extremes are deadly. Yet certain organisms, thermophiles, not only survive, but flourish. Microscopic bacteria and archaea thrive in these scalding pools, their enzymes adapted to function where ours would collapse. Some even give the pools their vivid colors, turning water brilliant shades of orange, yellow, and green. Higher organisms, such as tiny worms and crustaceans, are sometimes found enduring heat that seems unimaginable. These species reveal that the boundaries of life are far wider than we once thought. To peer into a boiling spring and see life stirring is to witness resilience at its most astonishing. In places that appear inhospitable, nature writes new definitions of possibility, showing that survival is not limited by our imagination. Others thrive in lakes of pure acid. There are lakes on Earth so acidic they could dissolve metal, places that seem utterly hostile to life. And yet, even here, microbes persist. In the Dalal pools of Ethiopia or in abandoned mine drainage, acid-loving extremophiles thrive where pH levels drop close to zero. Their proteins and membranes are built to resist corrosion, allowing them to carry out life's processes in environments that seem like chemical nightmares. Some create colors so vivid, reds, oranges, and yellows, that the landscape looks painted. These organisms expand our understanding of what life can endure, hinting at possibilities beyond Earth. If creatures can thrive in acid lakes here, perhaps they might survive in the harsh chemistry of alien worlds. In their quiet existence, these microbes remind us that life is stubborn, inventive, and unwilling to yield, even to conditions we call impossible. Bacteria live miles beneath Earth's surface. Beneath our feet lies a hidden biosphere, stretching miles into the bedrock. Here, in tiny cracks and pores filled with water, bacteria endure under immense pressure, isolated from the surface world for millions of years. Some survive on hydrogen gas released by the slow reaction of water with rock. Others consume traces of methane or sulfur compounds. These microbes live at such depths and on such long timescales that their life cycles are measured in centuries rather than hours. Scientists drilling into deep mines and boreholes have found thriving microbial communities where sunlight has never touched. This deep biosphere may contain more biomass than all the oceans combined, an invisible realm of life quietly pulsing far below. It changes our view of Earth. The planet is not just alive on its surface, but alive throughout its depths, humming with unseen persistence. Some creatures survive on nothing but sulfur and heat. Near hydrothermal vents, where scalding water gushes from the seafloor, strange creatures thrive without sunlight or oxygen. Giant tube worms, clams, and crabs live in a world fueled not by photosynthesis, but by chemosynthesis, the conversion of chemicals into energy. Inside tube worms live symbiotic bacteria that use hydrogen sulfide, a gas toxic to most life, as fuel. These bacteria provide nutrients, effectively feeding their hosts from within. The worms, with blood-red plumes and bodies stretching meters long, look like alien beings rooted in darkness. To us, their world seems unlivable, hot, toxic, and pitch black. Yet here, life flourishes abundantly, proving that Earth does not rely solely on the sun. These sulfur-powered communities remind us that life is adaptable beyond measure, finding energy wherever it can, transforming poison into sustenance. Extremophiles show that life can exist in almost any condition. Boiling heat, freezing cold, crushing pressure, deadly radiation, acidic pools, alkaline lakes. Everywhere humans once thought life could not exist, it has been found. The creatures that inhabit these extremes are called extremophiles, and they challenge every assumption about biology. Some bacteria endure radiation levels thousands of times greater than what would kill us. Others survive desiccation so complete that they can lose nearly all their water, lying dormant for decades until revived. Collectively, extremophiles show us that the conditions for life are not narrow but astonishingly broad. This realization reshapes not only how we see Earth, but how we imagine life elsewhere. If microbes can thrive in acid, in ice, in boiling vents, then perhaps on Mars, Europa, or Titan, something lives unseen. Extremophiles whisper that life is not fragile, but tenacious, perhaps universal, waiting wherever conditions permit. Birds are living dinosaurs. When you look at a robin perched on a fence or a hawk circling high above, you are seeing the living legacy of dinosaurs. Birds are not just related to them, they are dinosaurs, the descendants of theropods like Velociraptor. Feathers first evolved long before flight, possibly for insulation or display, and were later adapted for gliding and soaring. Even now, bird skeletons carry echoes of their reptilian ancestors, from their hollow bones to their clawed feet. The realization that birds are dinosaurs reshapes how we view the past. The mighty lineage of creatures that once ruled Earth never truly ended, but took to the skies. Every chirp, every flutter, every flock in flight is a continuation of a story more than 200 million years old. Dinosaurs still walk among us. They perch in trees and sing at dawn. Crocodiles have changed little in 200 million years. If birds are the dinosaurs that evolved, crocodiles are the ones that endured. Modern crocodiles closely resemble their ancient ancestors, having changed little in form for over 200 million years. Their bodies are so well adapted, armored skin, powerful jaws, and stealthy ambush tactics, that evolution had little reason to alter them. Crocodiles witnessed the rise and fall of dinosaurs, the splitting of continents, and the emergence of mammals, yet they remain. Their survival owes much to patience and efficiency. They can slow their metabolism, endure long periods without food, and thrive in rivers, swamps, and coasts across the world. To see a crocodile sunning itself on a riverbank is to glimpse prehistory alive in the present. They are living fossils, reminders that sometimes the greatest evolutionary strategy is not constant change, but timeless perfection. Some fish have lungs as well as gills. Most fish breathe only through gills, extracting oxygen from water. But some species bridge two worlds, carrying both gills and lungs. Lungfish, for example, gulp air at the surface, using primitive lungs to survive when ponds dry up. In Africa and South America, they burrow into mud during droughts, cocooning themselves and breathing air until the rains return. These dual-breathing abilities are evolutionary relics, hints of the transition from water to land hundreds of millions of years ago. Such creatures remind us that the boundary between aquatic and terrestrial life is not absolute but fluid, a gradient of adaptation. To see a fish surface to breathe is to glimpse echoes of our own origins, for it was fish like these that gave rise to amphibians, reptiles, and eventually mammals. Their lungs are not just survival tools, they are windows into our deep past. Whales evolved from land-walking mammals. It may be hard to imagine, but the largest animals in Earth's oceans once walked on land. Around 50 million years ago, a wolf-like creature called Pachycetus prowled ancient shorelines. Over time, its descendants adapted to life in the water. Their limbs stretched into paddles, nostrils shifted to the tops of their heads, and tails grew powerful flukes. Bones of early whales like Ambulocetus, the walking whale, show animals equally at home in rivers and on land. Gradually, these creatures gave up the land altogether, transforming into the fully aquatic whales we know today. When you see a whale breach the surface, you are not just looking at an ocean giant, but a mammal whose lineage returned to the sea after a long evolutionary journey. Their songs and migrations carry with them echoes of a forgotten past, a reminder that even giants were once wanderers on land. Horses' ancestors were once the size of small dogs. Modern horses are powerful animals, capable of galloping across plains at great speed. Yet their ancestors looked very different. 55 million years ago, a small creature called Eohippus, or dawn horse, roamed ancient forests. Barely the size of a fox terrier, it had multiple toes instead of hooves and browsed on leaves rather than grazing grasslands. As climates changed and forests gave way to open plains, horses grew larger. Their toes fused into hooves for speed, and their diets shifted to tough grasses. The evolution of horses is a vivid example of how life responds to changing environments, reshaping bodies over millions of years. When we watch a horse run, it is easy to forget that it carries a deep ancestral story within its stride. From tiny forest dweller to thundering grazer, an animal whose journey mirrors the shifting landscapes of Earth itself. The blue whale is the largest animal ever to live. Bigger than any dinosaur that ever walked the Earth, the blue whale is the true giant of our planet. Reaching lengths of over 30 meters and weighing as much as 200 tons, it dwarfs every other animal in history. Yet this leviathan feeds on some of the smallest creatures in the sea, krill, tiny shrimp-like animals eaten by the millions in a single gulp. With a heart the size of a small car and a tongue heavier than an elephant, the blue whale is both awe-inspiring and gentle, moving with surprising grace through the water. Its low-frequency calls travel for hundreds of kilometers, carrying songs across oceans. To share the world with blue whales is to know that Earth still harbors wonders beyond imagining, living monuments to life's power and scale, breathing reminders of just how vast biology can become. Some insects have remained unchanged for hundreds of millions of years. Insects are among Earth's greatest survivors, and some lineages have remained virtually unchanged since the time of the dinosaurs. Creatures like silverfish, dragonflies, and cockroaches appear in the fossil record, looking remarkably similar to their modern descendants. Dragonflies once grew to wingspans over 2 feet across, soaring through primeval forests more than 300 million years ago. While their size has diminished, their design has endured, perfected for agility and speed. Cockroaches, often maligned, are evolutionary marvels, surviving multiple mass extinctions with hardly a shift in form. To look at these insects today is to see living fossils, creatures whose bodies have already passed the ultimate test, time. Their persistence tells us that evolution is not always about change. Sometimes the greatest success lies in stability, in a design so effective it needs no reinvention for hundreds of millions of years. Life has recovered from 5 mass extinctions. Earth's history is punctuated by catastrophe. At least 5 times, mass extinctions have wiped out the majority of life. From the Permian extinction, which erased more than 90% of species, to the asteroid impact that ended the reign of the dinosaurs. Each event reshaped the planet, emptying ecosystems and leaving space for new forms to rise. After devastation, life rebounded, diversifying into strange and marvelous new creatures. Without these extinctions, mammals might never have flourished, and humans might never have appeared. The resilience of life is staggering. Even when nearly all is lost, evolution continues, reshaping and renewing. Mass extinctions remind us of the fragility of existence, yet also of its tenacity. The living world is not a fragile flame but a wildfire, dimmed at times, but always rekindling, burning forward into new eras. Some seeds in Antarctica still hold DNA from ancient forests. Antarctica is a frozen desert today, but millions of years ago it was lush with forests of beech, ferns, and conifers. Evidence of this past still lingers, preserved in the frozen soil. Scientists have discovered ancient plant material, seeds and spores, that still contain fragments of DNA. These remnants reveal what once thrived in a land now buried beneath ice. They show how climates shifted dramatically over time, transforming green forests into glaciers. To hold such a seed is to hold a piece of a lost world, a genetic memory of landscapes long gone. Though these seeds no longer grow, their DNA is a record of Earth's living history, written into molecules. They remind us that even in the harshest, emptiest places, the traces of life endure. Whispers from ages when the coldest continent bloomed with green. The human body contains ancient viral genes. Hidden in the vast expanse of our DNA are fragments of ancient viruses, relics from infections that struck our ancestors millions of years ago. These viral genes, called endogenous retroviruses, make up nearly 8% of the human genome. Most are dormant, no longer capable of spreading disease, but some have been repurposed by evolution. One viral gene, for example, helps form the placenta, making mammalian pregnancy possible. In this way, ancient viruses are not just passengers in our DNA, they are part of what makes us human. Every cell in our body carries echoes of viral invasions long past, reminders that our genomes are not pristine, but patchwork histories of survival. We are, in part, built from the remnants of enemies we once fought. Life, it seems, turns even invasions into opportunity, weaving adversity into the fabric of existence itself. Every breath you take contains atoms from countless organisms. Take a breath, and you inhale more than oxygen. The air is filled with atoms that have cycled through countless beings before you. The carbon you breathe out may once have been part of a leaf, a bird, or a dinosaur. The oxygen you inhale might have passed through the lungs of an ancient mammoth or swirled in the blood of a whale. Because atoms are endlessly recycled, every breath ties us to the entire history of life. With each inhalation, we participate in an unbroken chain stretching back billions of years. Breathing becomes more than survival. It becomes communion, with forests, oceans, and creatures long vanished. To breathe is to share in the story of Earth, to carry within us fragments of all that has ever lived. Every breath is a reminder that life is not separate, but shared. All life on Earth shares the same genetic code. From bacteria hidden in deep-sea vents to oak trees reaching for sunlight, from hummingbirds to humans, all life is written in the same chemical alphabet. DNA, composed of just 4 nucleotides, underlies every organism on Earth. The universality of this code is astonishing. The instructions that build a mushroom are written in the same language as those that build a whale. This shared heritage suggests that all life descends from a common ancestor, a single spark billions of years ago that blossomed into endless forms. The fact that we share genetic kinship with insects, fish, and trees dissolves the illusion of separation. It reveals a profound truth. Earth's living world is one family, endlessly branching, yet rooted in the same origin. In every genome, from simplest microbe to human being, lies the same signature, a universal poem of existence. You are made of atoms forged in ancient stars. Long before Earth existed, stars lived and died in brilliant explosions called supernova. Within their fiery cores, elements heavier than hydrogen and helium were forged: carbon, oxygen, iron, calcium. When those stars exploded, they scattered these building blocks across the galaxy. Eventually, they coalesced into planets, oceans, and living beings. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were born in stars that died billions of years ago. To realize this is to feel both small and infinite. You are not separate from the cosmos, but a piece of it, carrying stardust in every cell. The universe dreamed itself into atoms, and those atoms became you. When you look at the night sky, remember that you are not just gazing at stars, you are gazing at your own ancient kin. And so, dear listener, our journey through the wonders of life on Earth comes to a quiet close. Together, we've drifted across forests and seas, deserts and mountains, through the deep past and the hidden present. We've wandered with ancient creatures, glowing worms, and whales that sing across oceans. We've followed the story of life as it stretched, adapted, endured, and reshaped itself again and again. If your eyes feel heavy now, you can let them close. Let the rhythm of your breath become steady, like waves upon a shore, like the beating of wings, like the tide of life itself. Each breath connects you to everything that has ever lived, a single strand in the vast unbroken web of Earth's story. If you've enjoyed this journey, I invite you to like, subscribe, or leave a comment when you next awaken. It helps this channel continue to grow, and it lets us keep sharing these quiet stories of wonder with the world. But for now, there is nothing more you need to do. You are part of this planet, part of its ancient rhythm, part of its great unfolding mystery. Let that thought cradle you gently, like the sea holding its creatures, like the earth holding all its life. Sleep well, dream softly, and remember, you carry the story of stars and oceans within you. Good night.